It stands to reason that if we have, say we know something about a function's derivative, we don't know the actual function yet, but we know something about its derivative. It stands to reason that we should be able to back up the process, so to speak, and find out from the derivative, find out what the function was. A good example is, if we have a position function, the derivative of its velocity. Well, let's say we observe a vehicle or an object up and down, and we can figure out the velocity function of that particular object. Well, if we could go, that's the derivative of the position function. So I've got the derivative. Can I get the position function off of that velocity if I know a function that goes with the velocity? So that's just one example, but you'll see some others as we go along here. So hence the name antiderivative, because I want to back up the process. I'm going to start with the derivative and see if I can come up with the function for that particular function, for that particular derivative. Okay, so let's say I've got f of x equals x squared. So I'm going to find f, a function f, such that f is the derivative. I'll say it differently. Find f so that f is its derivative. I'll say it that way. Sounds better to me. So I want to find a function. This is the derivative. I want to find a function that has that as its derivative. So that's big F. They call it big F in this case. Okay, let's think about it. Big F is a function that has this as the derivative. Well, what power of x does this need to be? And if you know the answer already, let others think about it here. If this is the derivative, what power does this need to be to have an x squared as its derivative? Well, does it have to be a third power? It has to be third power because if I do the derivative of the third power, I get a second power. So I go from x to the second to x to the third because that's what it needs to be. Now the problem with that is, if I just say x cubed, that is not, the derivative of that is not x squared. The derivative of that is 3x squared. So how do I compensate for that? Well, if I put up here a 1/3 in front, wouldn't that fix our little problem here? Because now, taking that, if I do the derivative of that, don't I get x squared? The derivative of that is x squared. Yes? Okay. Well, what I found here is, through this process, I started with x squared, now I've gone to 1/3 x cubed. This is the antiderivative of f of x equals x squared. That's an antiderivative because I've done this thing backwards, so to speak. Anti, opposite, right? That's what I've done. This is an antiderivative. Now, I say an antiderivative because another possibility, I could do f of x equals 1/3 x cubed plus 5. That's an antiderivative of x squared. Why? Well, the check is go back and do the derivative, all right? So if I do the derivative of this, what do I get? Well, the derivative of that's x squared. What's the derivative of that? 0. So that's another possibility. What about 100? That'd be another possibility. What about minus 756.1. Okay? You get the idea here. Yeah, so typically what we say is the general antiderivative of f of x, here's how we put it. It's big F of x equals 1/3 x cubed plus any number that we could think of, which that would include negative numbers there. C for constant, it's usually capital C that they use, but that is the general antiderivative of this particular function. Okay? Because we can put any constant we want here, the derivative of that is still going to be that, so that's what we're saying. Okay? All right, now, to help us along the way here, let's think about what happened actually. So I went to the antiderivative. Well, it's an opposite process altogether, because to get an antiderivative here, this antiderivative, I've added one. Derivative, you subtract one from the power. Antiderivative, you add one. So that makes sense for opposite. And then what else did I do? Well, I divided. Essentially what I did is I divided by that power there. The 3, I divided by, -1 divided by 3. And I could write it as x cubed over 3. So I divided by 3, which, in a derivative process, I multiply by the old power. I multiply by the old power, right? So you see, it's kind of an opposite process. And then, of course, I add the plus c. But so that's, if I have f of x equals x to the 5th, then the antiderivative big F of x would be, I do the opposite. I add 1, get the new power, divide by that new power, and then add the plus c there. So it's the opposite all around, so to speak. Add 1 and then divide by the new power there, and that'll get you the antiderivative. So in general, here's how the power rule for antiderivatives works. For f of x equals x to the nth power, the antiderivative is big F of x equals, so I add 1 to the new power, and then divide, so to speak, by that new power. And that's kind of another difference between derivatives and antiderivatives. In derivatives, you bring down the old power and make a new power. Well, in antiderivatives, you make the new power and then divide by that same power. So it's kind of different that way too. But anyway, that's the process. And I add 1 instead of subtract 1, and then I divide by that new power, and then don't forget your plus c. Okay. Now there is one little catch. Because of what you see there, n, so this works for any power of n, except n can't be -1. And if you think about it a little bit, you can see why that is, because what would happen, it'd be okay here. I could do n equals -1 there, but what do I get if I do n equals -1 here? 1 divided by 0, that's not a number. So you can't do n equals -1 with this. So it works for any power of n, positive or negative powers of n, fractions, decimals, negatives. Works for any negatives, any fractions, any decimals, except -1. Just can't use it for -1. Okay. All right, so let's do a couple more here. So f of x equals x to the negative 8. What is the general antiderivative for it? Big F. Well, antiderivative, so I'm going to get a new power, and I'm going to get the new power by adding 1. Be careful with the negative. Again, negative 8 plus 1 gives you, not negative 9. Negative 8 plus 1 gives you negative 7, doesn't it? So I would divide, take 1 divided by negative 7. And then, yeah, we are kind of stickler. Don't forget the plus c. When you're doing antiderivatives in general, you need to add the plus c. I guess not the only thing to clean it up, just say negative 1/7. X to the negative 7 plus c, or you can flip over. I would, since it started like that. All right, f of x equals x to the 2/3. What's the general antiderivative for it? Big F of x would be what? So x, start with the new power. What would be the new power? 2/3. So I'm going to add 1 instead of subtract 1 since I'm doing the antiderivative. 2/3 plus 1. Well, again, just think 2/3. So I do the denominator 3 here. So it'd be 3 over 3 would be the value of 1. So 2/3 plus 3 over 3. That's 5 over 3, right? Now, I'll write it this first time this way. So it'd be 1. So I would divide, take 1 divided by 5/3. And then plus c. Don't forget that. But let's think about this. And then make another generalization here. So I've got 1 divided by 5/3. Doesn't that mean 1 times the reciprocal, 3/5? That's just 3/5. So this is 3/5 x to the 5/3 plus c. And it's fine to go through that process each time if you want to, but let's just notice here, if I've got a fractional power here, then what goes here is the reciprocal of that. So instead of having, just do the reciprocal up front. And again, technically that's what we're doing each time, but it really shows up here what I'm doing with that. So if I've got f of x equals x to the negative, well, let's say 5/7. The antiderivative would be f of x, big F of x equals, all right, so start with the new power for the antiderivative. New power would be negative 5/7 plus 1, or negative 5/7 plus 7 over 7, which would be 2 over 7. But up front, we're dividing by that, so it actually turns into reciprocal, 7/2. And then plus c. Yeah, that's, just jump to the right to the reciprocal there. Two 7, so the reciprocal is 7/2. Is that okay? Now, f of x, one to think about also, and we'll do some others as well, but f of x equals 7. How do we handle that for antiderivatives? Well, the derivative is 0, but the antiderivative is something different, isn't it? Big F of x, antiderivative, what will we do there? Well, I don't have x to a power there. So what is the power of x going to be here? It's got to be x to a power. Well, technically speaking, it doesn't show as x to any power, but what is the power we're starting with? X to the, zero power, isn't it? So if I add 1 to the 0 power, I just get x to the 1, or just x. So if I start with a constant, the antiderivative is going to be 7x, or that number times x, and then plus c, of course. See how that works? Yeah, so if you start with a constant, your antiderivative is going to be that constant times x, and then plus your c. But, all right? Works kind of the opposite. All right, now, just thinking, we'll do some others here. Let's talk about the trig functions here. Starting with f of x equals cosine x, the antiderivative. What about that? So obviously not the power rule here, but so what is the antiderivative is the function whose derivative is cosine of x. So is there a function whose derivative is cosine of x? Sine of x, isn't it? Sine of x. And then plus c there because, again, the derivative of c is 0, so that would give you the right derivative. So, yeah. Now, if you do sine of x, the antiderivative, a little trickier, not much, but a little bit trickier. So I want a function whose derivative is sine of x. Why is it not cosine of x? Let's see. Well, if I did cosine of x, the derivative is negative sine of x, right? Not positive sine of x. So what do I need here for the antiderivative? I need negative cosine, don't I? Negative cosine of x. Now, so those are good because they're basically the same as the derivatives except what? The derivative of cosine is negative sine. The antiderivative of cosine is positive sine. The antiderivative of sine is negative cosine. The derivative of sine is positive cosine. So the antiderivatives of sine and cosine are the same except for they're the opposite. The signs work the opposite, don't they? Cosine, the antiderivative is positive sine. Sine, the antiderivative is negative cosine. So it's the same, except the signs are opposite. Now, the others. The others, well, it gets complicated. For example, we can't do easily, we can do them, but antiderivatives, but we can't do them easily. All of the trig functions, like tangent, doesn't have a nice, easy antiderivative, and I'll talk about that more in a second. What does have a nice, easy antiderivative is secant squared x. Why is that? Well, secant squared x has a nice antiderivative because what function has a derivative that's secant squared? Tangent, right? Tangent's derivative is secant squared, so secant squared x, the antiderivative is tangent x plus c. See that? So what would be another easy antiderivative? Well, think about the derivatives of some of the functions. Another easy antiderivative would be secant x tangent x. The antiderivative there is nice because that would be secant x plus c. Yeah, because the check is do the derivative of that and get that. Yeah, the derivative of secant x is secant x tangent x. So the antiderivative of secant x tangent x is secant x plus c. You kind of have to think backwards, so to speak, there. And that's why I was saying f of x equals tangent of x. I mean, we can do the derivative all day long, but the antiderivative, that's not going to be an easy one because there's not a function that we've talked about yet, nice, easy function, whose derivative is tangent of x, okay? So this is not, let's call it not an easy one. There is one, but yeah, there's not an easy antiderivative of that because there's not just an easy function whose derivative is tangent. So those are the things you look at for those trig functions. The nice ones, cosine and sine are probably the main ones we'll talk about. Secant x, secant squared x, and these others come up occasionally, but just be aware. All right, now, a couple other things here about our antiderivative. F of x equals 10x. So yeah, what happens if we have a number in front? Well, the antiderivatives, not so bad, of those, because they're just numbers in front. All right, so we got 10, and that's x to the first, so the new power, let's do it this way. Yeah, so the 10, we're just going to multiply whatever the antiderivative of the x is. We're just going to multiply that by the 10. The 10 is just a number. So we can do this. All right, so we add 1, got x squared, so we divide by the 2. We got 10 times a half. So basically we're dividing the 10 by the 2. So it'll be 5x squared plus the c. 5x squared plus c. Yeah. So whatever your new power is, you're just going to divide your coefficient by that. No problem there. All right. Can we do this one? F of x equals 8x to the third plus 5x to the fourth minus 9. Can we do an antiderivative of that? Well, good news on the antiderivatives is they're much like the derivatives in this regard, in that if you've got pluses and minuses between your terms, you can do those all day long. All right, so I'm going to do the antiderivative here of 8x cubed, which would be 8 times what? 1/4 x to the fourth, add 1, plus then the antiderivative of that one, which would be 5 times the new power be x to the fifth, because I'm adding 1, so I divide by 5, make it 1/5 x to the fifth. And then that's minus, so I can do the antiderivative of that. We talked about that earlier. If you got a number, the antiderivative is just adding x, minus 9x, and then plus your c. So yeah, the antiderivatives are much like the derivatives, and if you've got pluses and minuses between them, you just do the antiderivatives all separately. So we get 2x to the fourth plus 5's cancels, those would be x to the fifth, minus 9x plus c as the answer. Okay? Similarly, f of x equals the square root of x plus 1 over x to the fourth. Well, that's 2 added together. However, you see there, we might want to alter the appearance, if you will, of f of x before we do the antiderivative. Probably I'd want square root of x in the power form, x to the 1/2 power. And then what would I want here? 1 over x to the fourth. Instead of 1 over x to the fourth, make it x to what power? -4 power, right? So just change those ever so slightly, then I can get my antiderivative just by doing power rule, antiderivative power rule. So x, new power would be 1/2 plus 1, so that's 1/2 plus 2 over 2, that's 3/2. And we talked about that. I divide by 3/2, but that's just going to mean the reciprocal up here, so it'll be 2/3 next to 3/2. And then here, the next one would be x to the negative 4, so that would be, the new power would be negative 4 plus 1, so that's negative 3. And so I do 1 divided by negative 3 in front of that, and then plus your c. So it's 2/3 x to the 3/2 minus 1/3 x to the negative 3, or equivalent version, plus c. The antiderivative there. Now, one quick little point here. Yeah, that's if you got pluses and minuses. What if you have what if we have divide? Well, we have divide. Unfortunately, just like derivatives, antiderivatives, you can't do the antiderivative of the top divided by the antiderivative of the bottom. That's the same in derivatives, it's the same in antiderivatives. Okay? So we can't, if you got divide and you're trying to do the antiderivative here, well, you have to do something to actually get the antiderivative of it. One thing we can do, and in this case it works, one thing we can do here is, yeah, we can just take 5x cubed and divide into all those. That's one possibility. If you can do that, then that's one fix. That won't always be a fix, but if it's just a monomial like that, you can do that. So that makes f, 2x minus 9/5 x to the negative 2 plus, and this would be 1/5 x, what power there? Because you're subtracting, right, the powers. So this power would be 1/2 minus 3. 3 is 6 over 2, so that'd be negative 5/2 power. I'm subtracting those powers there. With me there? Yeah, so now I don't have the problem of divide. I just have 3 separate terms. So the antiderivative would be, well, it'll be 2 times the antiderivative of that, which would be 1/2 x squared, minus 9/5 times the antiderivative there, which is, the new power would be negative 1, so it'd be 1 divided by negative 1. And then 1/5, the x, the new power would be negative 5/2 plus 1, so that's negative 3/2. So I'd multiply by negative 2/3, the reciprocal of that, and then plus c. And simplify that. 2's cancel, so you'd have just x squared here. I got a minus 9/5 times negative 1, basically, so it'd be a positive 9/5 x to negative 1. That would be a minus, 2/15 x to minus 3/2 plus your c. Yeah, we'll be stickler for the plus c there. So. Yeah, so just like derivatives, antiderivatives, you cannot do the antiderivative over another antiderivative. Or, and we'll talk about these just for another example. Yeah. Unfortunately, when you have times, again, it's important to understand, you just can't do the antiderivative times the antiderivative. So the antiderivative is not 1/3 x cubed times negative cosine of x. It is not that. It's complicated. We'll talk about how we can do those things, some of them anyway. To get more of those, you would have to take the adventure into the second calculus, or what we do in the second calculus. But we'll talk about one or two types of those that we can do with times. But it's not going to be antiderivative times antiderivative. That's for sure. Okay. Just like derivatives, multiplication, division, antiderivatives get complicated. Let's just say it that way. Multiplication antiderivatives and division antiderivatives, it gets complicated. Unless you can simplify that, multiply it out, divide it out. Unless you can do one of those two things, it is complicated.